Are you in the meeting?
What's this reading proposed? I can try rejoining though. There we go.
You are now panelists.
Giving a request to share as well.
Can people also hear me? That's check that. Can you open chat? Can people also hear me?
It's echoing.
It's echoing. Why is it echoing? My audio as well. Huh.
Is it not the room that's echoing?
When you get on
Yeah.
Let me just check some settings. That might be. The echo is coming from me speaking and the mic going to the speaker and coming back.
So do you,
That's the right thing.
Yeah. Is it a tiny echo?
We could turn the mic volume down a bit, maybe.
Maybe. That's just. Oh, this is better. The way you want to.
What? It's for Zoom people. Yeah.
Is it echoing? So, anyone? Anyone there? Hello? 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 It's just the usual room. Okay.
Okay, so it's fine. What should we do about the mic? We just hold it like this?
Yeah, there's a clip.
Oh, yeah, there is.
Yeah, there's a clip.
But we'll pass it back and forth for the intro.
Yeah,
No.
and then you can flip it.
Where?
Yeah. You can test out if it works.
Oh, should we just use two?
But yeah. You want me to do instructions or?
Oh, yes, definitely. And is it? Oh, when it doesn't say.
Back there.
Oh, 9. Okay. Do you want to start the introduction?
Yeah. So keep that in mind for time as well.
Yeah.
All right. This one's off. Yeah. All right. Good afternoon. How's everyone doing? All right. Let's see what's coming up today. Project 3A, it's going to be due next Friday. Just show of hands, how many people have already formed partnerships? How many people have started working on this? All right, start working on it soon if you haven't already. As I've said, the longer you work on this, the less time you'll need to work on Project 3B. So this is definitely one of those where you want to start early. Other than that, we do have a lab. The Tetris lab is due, I think, this Friday. But it's optional. You don't need to finish it. It is going to be useful if you want to practice using the graphic system that we're recommending you use for Project 3. Other than that, today our lecture is going to be on software engineering. We kind of like to do this thing where some of our long-term TAs get to run these lectures, kind of share their experiences within the industry when they have done some internships. So today we have 2 guest lectures here. We have Stella. We have Kanav. All right. It's time to get started. I'll leave it up to you.
Awesome. Hi, everybody, and welcome to Software Engineering Lecture 2. Today, we're going to be covering industry practices for collaboration. And we're going to start off with an introduction. So my name is Stella, and I'm a 4th-year computer science major. It's my 4th semester on 61B staff. I love it. Definitely recommend you apply. And I was an intern at Microsoft and Oracle, and I'll be speaking a little on that experience today. And my favorite Taylor Swift album is Reputation.
Okay. Hi, everyone. My name is Kanav. I'm a 4th-year EECS major. This is my 3rd semester on CS61B staff. I was previously an intern at a data privacy startup and then at NVIDIA. And my favorite Taylor Swift album is Folklore.
All right. So we wanted to start off lecture today by opening up a question to everyone here in the audience. And can you please turn to everyone around you and discuss just for 1 minute, what comes to mind when you think about a software engineer's day-to-day work? Yeah, you should.
Okay, that's a good idea.
All righty, for the sake of time, let's all come back together. All right, can you raise your hand if this image is what came to mind when you think about a day-to-day job of software engineer? It did for me, for sure. So maybe when you think about a software engineer's job, you picture them sitting alone at a computer in a coder basement. And today, I want to challenge this common perception you might have that software engineering is mostly coding by yourself, because that's a myth. So let's start by acknowledging that collaboration is at the heart of software engineering. This diagram up here represents the different layers of collaboration that you, as a future software engineer, will engage with throughout your career. So at the broadest level, we have customers. They're the furthest away from you as they're the most difficult to communicate with. And they're going to be the end users of the product you're building. Next, we have past and future employees. This includes people who worked on the code base before you and those who will work on it after you. So writing clean code is essential because it's going to ensure that future engineers can work off what you did. And moving more inward, we have product managers and designers. They're responsible for defining what needs to be built based on customers' feedback and business goals. And so collaboration with them ensures you're building the right features. And then we have engineers, your immediate team members. And this is where the day-to-day collaboration happens. You'll be working closely with other developers, reviewing each other's code, and solving technical challenges together. And at the center of this is you. So this image up here is a modern tech company's workspace. Look at how open the office setup is. It's designed this way on purpose to foster collaboration. So while this office space does have its advantages, right, like efficient collaboration, and it allows for spontaneous conversations, it also has some drawbacks because it only works in real time and it doesn't work for remote engineers. So today we're excited to explore how to overcome these challenges with agile frameworks and Git for effective collaboration in software engineering. And so today we're going to talk about this term called agile development, and we're going to define it on a pretty large scale. We're focusing on industry applications, specifically that might not be relevant to your 61B coursework, but essential later on in your career as a software developer. And so to explain agile development, I'm going to go into a little story time, a little demo of me and Kanav trying to build something. We were actually at Wojciech Bagels last Sunday talking about how much we love the Berkeley food scene. And this led us to a conversation about how we could maybe use our programming skills to develop an app for food ratings and reviews. And so we're going to call our app 61 Belly. Has anyone heard of Belly before? Food rating app? That's our inspiration. And its purpose is going to be rating foods and sharing culinary opinions. And so some key features, we want to include user reviews, a numerical rating system, photo uploads, and social sharing capabilities. All right, so our first step as we embark on creating 61 Belly is talking to customers. Well, why does this even matter? First up, it ensures we have a product market fit. This means we're not just guessing what people want, we're actually building something they need. And next, talking to customers lets us dive deep into their real needs and pain points. Lastly, having these conversations will reduce the risk of developing any unwanted features. By getting feedback really early on in our process, before we start to code, we can avoid wasting any time and resources on things that don't resonate with our users. So overall, it's making sure we're on the right path. And so we could ask them a variety of questions, including those on the board. So 1 week later, after conducting some user interviews, We found these top suggestions, like an easy registration, a customizable profile, reviews and rating systems, and 3 more. But because you're all here in person today, we wanted to ask you, do you have any suggestions of what we should put in our 61 Belly app? And we'll take a couple raise of hands. Yeah. Yeah, categorizing restaurants based on different cuisines. That's a great one. Any others? Yes. Yeah, allergen information for the different restaurants we're having on our app. That's great. Yeah, let's take a third. Yeah, location services. Awesome. These are all amazing ideas and ones we should definitely incorporate in our 61 Belly app. All right, so given our findings of all these different things we need to create, now what? How are we going to plan building our app? How are we going to adapt to maybe some changing customer needs? And how will we work together with limited time? And how about asynchronously? Me and Kanav are both pretty busy people. So this leads us into the importance of agile software development. So Atlassian is a big software company that provides tools for developers to help teams collaborate and manage their projects. And they define agile development as an iterative approach to delivering a project, which focuses on continuous releases that incorporate customer feedback. But let's break that down. I think it's a set of values that guide software development through 4 key principles. The first, agile values individuals and interactions over processes and tools. This means we prioritize strong team communication and collaboration, ensuring that everyone's input is valuable in shaping the product. Second, in Agile, we focus on delivering working software quickly, and the goal is just to get a basic version out into the user's hands for immediate feedback as soon as possible. Third, the value of customer collaboration. And this emphasizes collaborating with the customer throughout the entire process of building a project. And so we're going to adapt to users' changing needs. Like, for example, maybe we needed to prioritize a better photo upload feature based on some feedback we got. And finally, Agile promotes flexibility and adapting to change rather than sticking to just one fixed plan. For example, say our competitor launches a super similar feature, then we want to pivot to add some unique elements that differentiate our product. So now we're going to get into more the nitty-gritty of Agile development with some more keywords. So starting out, we have this word Scrum, and it's actually the most popular of Agile frameworks used to manage and structure work. And at the heart of Scrum is something called a product backlog. And this is a list of tasks or features that needs to be developed. And they're often written as something called a user story, which describes the feature from the perspective of a user. And secondly, Scrum will break down these tasks in the backlog into something called a sprint. And so sprints are manageable pieces, which we store in a sprint backlog. And they typically last between 1 to 4 weeks. And during this sprint, we want to keep everyone aligned. So Scrum will hold daily stand-up meetings. And these are short check-ins to make sure that team members can discuss what they've accomplished the day before, what they're planning on accomplishing the current day, and any blockers they might face. And this just keeps communication flowing and addresses any issues really early on. And finally, we would have a working increment of our product. So 4 key stages of this Scrum process. And note that this process of planning is not exclusive to software engineering. It can be helpful for managing some large-scale projects. All right, let's head back to 61 Belly. Me and Kanav are going to start our project. We know our users' needs, but now we need to organize them into the Agile framework. And so we encounter this long list of tasks that needs to be accomplished, and we're going to put that in our product backlog, also known as our ultimate running to-do list. Using Scrum, we're going to break down this to-do list into smaller manageable pieces called sprints. Every sprint will begin with a sprint planning. And during this, our team's going to define what we can deliver during that sprint, as well as how we're going to break up the tasks and divide them between the 2 of us. So we discussed that for our first sprint, our priorities are registration and the reviews and rating system. And this will allow us to get our app out as soon as possible, launching it on the App Store. For our second sprint, we agree that search options and sharing capabilities are the priorities. And lastly, we plan to add our nice to have features, including the customizable profile and high quality photos to our last sprint. So now our plan is complete. Our sprints are all planned. But how do we track progress and communicate well throughout the process of actually doing these tasks? What tools do software engineers use to track and put these plans into action? Well, Jira is a software application developed by Atlassian for issue tracking and project management. It can help in a variety of ways, like planning your sprints, customizing workflows, helping you manage the backlog, and report and dashboards are really essential here. So let's create a Jira project for 61 Belly. All right, so first we're going to organize all our tasks into Jira's backlog. And you can see our tasks are listed from top to bottom here. And remember that a product backlog is just a list of tasks or features that needs to be developed. And so each item in a backlog is called a ticket. And so let's break down what this ticket exactly entails. It includes a title up here, easy registration, a description, and then also a bunch of other features like an assignee. You can add labels, which sprint it belongs to, comments. There's also so many more cool features, like you could nest tickets to create parent and child items, or you could add like an estimated time to completion to help notify your team members how long this might take you. And so we're going to go ahead and create our first sprint in Jira. And so to do this, we're going to follow our original plan of prioritizing the easy registration and the reviews and rating system. So as we go look at our first sprint up at the top, you can see that we are prioritizing these two items from our backlog. So now we're going to head over to something called a Scrum board to see how tasks are doing in the current sprint. And a Scrum board is a visual tool used to track the progress of tasks. It typically consists of columns representing to do, in progress, and done. And team members will move these tasks, often represented as sticky notes, to across these columns as they progress through their workflows. And this helps the team visualize their work. And so at my summer internship, our Scrum board actually had 2 additional columns, one for testing and one for code review. And this just shows how customizable Jira's tools are for different teams' needs.
How did you keep track of what you're doing right now and what was on your to-do list? Oh, in progress, right?
Yeah, in progress, exactly. Great question.
Was it? It was a different label than what I used.
Yeah, definitely. Super customizable from team to team. And we'd also always pull up this Scrum board at our daily stand-up meetings. So every morning, it was 11 a.m., we pull up this board for everyone to stay on track. And so 1 week later, we've actually finished our sprint and launched the app. Woo! And now we're going to go ahead and plan our second sprint. And originally, we were planning on working on the search and filter and the social sharing options. You can see those 2 tickets up at the top.
So I'm going to interrupt you one time.
Yeah.
Back one. So whenever you're doing in progress, in terms of granularity, let's say in a week, how many tickets would you do?
Probably 2.
2. Okay,
Yeah.
got it. So as opposed to they're kind of higher level of abstraction.
Definitely.
Right, okay. Right. So I was used to a finer granularity of ticket where you maybe had like 7 or 8 flight in a week, and you had sort of 2, like what I'm literally doing now, what I'm doing this week.
Interesting.
Okay,
Yeah.
So you had 2 at a time.
Yeah, usually 2 tickets a week. They were usually nested under like a parent ticket. That was like the overall feature I was building. And then it'd be 2 little tasks, like make a button for this and make some functionality to test this. Yeah. So now we're working on our second sprint, as I said, but a customer is going to come and say they have a bug. We actually have no option right now for a customer who forgot their password to log in, which that happens to me all the time. So within our Agile framework, we can quickly adapt and adjust our sprint to include this. So now we can just add a ticket to our current sprint as we're planning, and we can launch into our next sprint, keeping the customer feedback in play. And this just reflects how flexible the Agile framework is. And so we're going to end our demo here in the middle of the second sprint, but hopefully this showed you how flexible and cool the Jira software is at Atlassian. All right, so as a summary, why do we even use Jira? Well, it helps us communicate who will be doing which task, when the task will be completed by, and how to adjust timelines to incorporate customer feedback. And we talked about completing these tickets in the backlog on a very high level, but how do we actually code them How are we going to collaborate with other developers, like your coworkers, future ones, even yourself, and see changes over time or revert back to previous versions? And so how about Google Docs? You know, Google Docs is great at working together on documents. Why don't we just put all our code in Google Docs? It's easy to use. It allows for real-time collaboration, maintains a version history like this screenshot below. So what's the problem with Google Docs? Let's take a minute to discuss with those around you. Do you see any issue of just putting all our code into Google Docs? I'll keep going.
Yeah.
All right. Well, hopefully you brainstormed maybe some of the disadvantages of Google Docs, but for the sake of time, let's talk about why Git is so much more powerful. Git's actually going to allow you to choose the files when you want to take a snapshot to include in your version history. It also allows you to collaborate on different variations of the project without the interference of others. For example, in Project 3B, you might be working on the line of sight ambition feature while your partner's working on the gameplay refeature. You don't want errors from one variation affecting the other variation. And so overall, Git is a very powerful tool that Kanav is going to talk about shortly. However, there is a disadvantage. Git is a more specialized tool for software development. It may not be as helpful for non-developers. So it's best paired with tools like Jira when working with non-engineering teams. And so I'm going to pass it off to Kanav to talk more about Git.
Okay, so yeah, as Stella said, I'm going to be talking more about Git. First, let's review a few Git commands that you may have already seen throughout this course. But now let's talk about what they're doing under the hood and understand how these commands help Git both be a tool for version history and for collaboration. So first, let's talk about commits, something that you may have already been working with in this course. What committing is it's like a stronger type of saving. It's stronger because one, you can save a snapshot of many different files at once and choose which files to include in your snapshot. And two, you can go back to the snapshot if you would like. With normal files on your computer, once you save it, it's hard to go back to a previous version, but Git stores all the previous versions. So we're going to go through a demo of how the Git workflow that you've been used in this class, Git add, Git commit, Git push, works with some terminology. So we start out with editing our files in our working directory up here. And this is what you have open in IntelliJ or another editor. Now, say you finish a lab assignment and you need to submit it. The first command you would run would be git add, which tells Git which files we want to save in our commit. So we see here, these files are put into a staging area, which is where Git is internally preparing our commit. Next, we run git commit, and this actually executes a save. Doing git commit creates a commit and adds that commit to the version history that's located in your local repository here. And your local repo you can actually find. It's stored in the .git folder within your working directory. And finally, you can use git push, and that sends your updated version history that includes the commit you just made to a remote repository for backup. Remote repositories are copies of your code that are stored on the internet, for example, GitHub, but other providers do exist. So far, you've been using git push to push your work to GitHub and then submit to Gradescope from GitHub. But remote repositories are so much more powerful than that. And as we'll see, they're really essential for collaboration. So now we've talked about the workflow for a single commit, but what happens when we have multiple commits? Well, each commit contains a pointer to the commit that came before it, except for that first commit you can see right here, which is often termed the initial commit. And together, these commits form our commit history. Each commit is uniquely identified by commit ID, which is a sequence of a lot of hexadecimal digits, but here we just show the first 6. And each commit also contains a commit message that developers write to describe the changes. What this ends up looking like is that commit history forms a linked list. And when we make a commit, this is the same as adding a new node onto our linked list with a pointer to the previous commit. So git log is another command that's used to help you navigate this commit history. You may have already worked with that in this class. And the way git log works is it takes advantage of this linked list commit structure. It starts from the current commit and keeps iterating through the previous commits until you reach the initial commit. And that helps you answer the question, what are all the changes that occurred to get me to my current code? And this is helpful to look at the history of the code base and who contributed various changes. Okay, so I've been talking about linked lists and commit history, and they're cool and all, but why do we even care about having this commit history in the first place? Well, what if you break something in your code and you want to go back to that? Or you might realize that something you did in the past was actually really good, and you want to go back to that and start building off from there. So what Git allows you to do, because of this version control system, is it allows you to go back to a previous version of your code that's saved in your commit history. The way this might work is you can use git log to determine the commit you want to go back to, and pass in that commit ID into either get checkout to inspect past versions, or git revert and reset to undo changes. And these commands effectively allow you to jump back to any past commit in the commit history based on the ID. So some tips on how to use Git's version control system effectively are to write brief but descriptive commit messages, so you know which commit contains what changes, and to also commit more frequently, so you have more checkpoints, and it's more likely there's a specific version of the code that you can go back to. Okay. So now we're going to be pivoting a bit, and we're going to now start talking about Git as a tool for collaboration. One key feature of Git that I mentioned earlier that fosters collaboration are remote repositories. These are Git repositories that live on the internet through providers like GitHub, GitLab, and Bitbucket. The cool thing about remotes is that they can be shared by multiple people, where you can represent each person with their local repository. So we see Stella's down here, and then mine on the right. Git push is a way to update the remote repository with your local changes. So both Stella and I can push our changes to the remote. But Git pull is the opposite. Both Stella and I can use Git pull to incorporate changes from the remote into our local repositories. So now how do we use these commands to collaborate? The answer to that is that one developer, like Stella, can push her changes, while the other developer, like me, could pull those changes in so I can work off her changes. And when using this Git push and Git pull like this, and you may find yourself using that in project 3 with your partner, it's very important, and this will come up later in lecture. Remember to pull before you push. On a high level, this is because you want to get the latest changes before you contribute your own changes. Else you will be contributing to an old version of the code. Pull before push is also something you should keep in mind for the project. And ideally, you should always pull before you even start to edit your code. Okay. So that was a high-level overview of how pushing and pulling works. But now let's see how this pushing and pulling that I just explained that enables collaboration can work with commit history, which enables version control. And this is really powerful and makes Git super effective. Remember that the commit history forms a linked list-like structure. Now, what Git push and Git pull do is they try to copy this linked list of commits back and forth between your local and your remote. This means that we can actually copy this linked list between different local repositories using the remote as an intermediate. And that means that multiple people can work on the same line of development. So let's take an example of how that works. And we're going to look at Stella's local on top, GitHub, which is the remote on the middle, and my local, which is on the bottom. And for simplicity in this demo, we're not going to be including the initial commit. Now let's say Stella creates a restaurant class and commits it. So we see that purple circle up there, and that represents her commit. Now Stella's going to push her changes to GitHub so others can access them. We see her commit now appears in the remote's commit history. I now want to access Stella's changes, so I'm going to pull from GitHub, which was just updated with her changes. Now Stella's commit is going to appear in my local repository. I know the color is a bit hard to see, but hopefully you'll see the light shade of purple around there. Now I'm going to work off the restaurant class that Stella created, and I'm going to create a cafe subclass because I'm really enthusiastic about adding cafes to the 61 Belly app. So we see that that commit now appears in my commit history right here. I'm then going to push my commit history to GitHub, and that'll show up in the middle row. And now Stella is going to pull the commit history from GitHub. Here, Stella's commit history originally had just reflected a past version of the remote. So hers was just this first purple create restaurant class, and it just didn't include this new change, which was the created cafe subclass commit. So all we do here is add on the new commits from the remote onto Stella's local. And this is what's called fast forwarding. Now, Stella's going to work on adding text reviews to a restaurant because that's the next feature. So we can see that commit appears here at the top. Meanwhile, I am still really excited about cafes. So I'm going to be adding a coffee ranking feature to cafe.java. And you can see my new commit appears down here at the bottom. Now, Stella's going to finish her work on text reviews. So she pushes her work to GitHub. And we can see that the GitHub commit history is now updated with this added text reviews commit. And now I'm going to be done with my changes. So I want to push to GitHub. But remember, I first have to pull before I push. So let's see what happens when I pull. When I try to pull from GitHub, I find that it's not as simple. While my local has this coffee ranking feature here, the remote has a text reviews feature after the created cafe subclass commit. This means that the remote's history diverges from my local history. So if the remote and local commit histories at one point shared a common ancestor commit, but have since then each gone their own way, that was we say that the two histories diverge from each other. So in the example before, we see that they shared the common created cafe subclass commit, but they since then went their own way. And the solution to diverging is to merge the remote and local commit history together. After Git merges the two together, it adds a merge commit to signify that the merge occurred. So the way this works is that the merge finds the closest common ancestor, that's what the point of divergence is called, of the two histories. Again, that was the cafe subclass commit from before. Then we look at what changes were actually made from this closest common ancestor to each of the two latest commits in the histories. This is basically asking the questions, how have the two histories diverged exactly? We can then combine these changes to merge. So raise your hand if you've seen a message like this ever pop up in your terminal. I know I have, yes. And in project 3, you might see this often. If you've seen a message like this is actually executing a merge, and it's specifically asking for the commit message used for the merge commit. So now let's go back to our demo and see how we will execute the merge when I'm trying to pull. The first step is to identify the closest common ancestor, which is the cafe subclass commit. And the second step is we combine the changes made from the closest common ancestor to the latest commits. We see that in the top on the GitHub, the changes made were editing restaurant.java, but on the bottom, the changes made were editing cafe.java. So these changes affect distinct files. So Git will automatically combine the changes together and complete the merge. And now Git will add a merge commit, which you can see in the bottom right in blue. The merge commit we make is going to have two parents. So now that I finished the pull process, which was extra long since it involved a merge, I can now push to GitHub. And we can see GitHub's commit history gets updated with mine. And now the merge commit appears in GitHub's history as well. So now let's continue on. We're going to cut out some of the past commits just to make space on the screen. I'm now assigned the task to add photos to reviews. So I'm going to work on that. And I can see that commit in the lower right corner right here, which points to the merge commit. So that's the latest one I just worked on. And I will push it to GitHub. So GitHub is going to get updated with my commit that I just made. Now, Stella is going to make a commit that adds star ratings to reviews, since customers have really been requesting that feature. Once Stella is done, she's going to push her changes to GitHub. But there's something that she has to do before pushing. Does anyone know what she has to do before pushing? Pull, yes, exactly. Stella's first going to pull in the changes. When pulling, she finds that her local history and GitHub remote history, they diverge. So we are going to have to do a merge. Same steps as before. Git will first identify the closest common ancestor, which is going to be the purple one on the left there. And after that, we're going to try to combine the changes. But here, both the changes involve editing restaurant.java. And that's a problem. So if both histories modify the same file in different ways, well, then which version of the file do we actually use in our merge commit? Git doesn't automatically know that, so it will not automatically complete the merge. And rather than jump to conclusions, Git is going to let the developer, or you guys, decide by resolving a merge conflict. So this is what a merge conflict might look like in your files. It's a bunch of weird text, and we're going to break it down. But on the top, that represents the local version of your code. And on the bottom represents the remote version of your code. And we resolve merge conflicts by choosing the correct version or combining parts of both between the local and the remote. It's really up to the developer. And we also remove all the extra text that Git adds, like these arrows up here and this head and these equals and this weird sequence of digits here. And we're gonna, after we do that, we'll test our code again and git commit to finish. So do we have any questions about merging or merge conflicts? Yes.
I actually had a question about Git checkout. So you said that it'll just inspect the code that is there on the remote repository. How does it really do that? Like, does it copy it on your local repository and then get it?
Yeah, so Git checkout can be used to view a specific commit ID or commit from your past history. And what it does is it makes your working directory, so what's open in your IntelliJ or your editor, reflect the contents of that commit.
Oh, I see.
But you can always then go back to the current place that you were at.
And that'll be done by the store.
I think you can do git checkout head or to get back to your latest commit. Yeah, great question. Do you have any others? Okay. So hopefully you saw from that example that merge conflicts are kind of messy. They require a lot of manual work. There's a lot of weird symbols that appear. So we want to minimize how often we have to deal with them. The problem is that they occur when we have multiple developers editing the same file in different ways, and that's almost inevitable. So can we even reduce the frequency of merges and merge conflicts if it's inevitable? Maybe one way we can do this is, can we let developers edit files independently and then only merge when necessary? One solution could be just to push and pull less. And the way this might work is that we're working on our features and we're only going to push and pull once we've completed our feature. So for example, Stella's working on the star feature, I'm working on the search bar feature, and we only push and pull when our features are done and ready to merge. But what if two people wanted to work on the same feature together? Like, let's say Stella wants to help me with the search bar feature. We need pushing and pulling to allow them to work off each other's changes. Pushing and pulling is really core to collaboration. So just saying push and pull less might not really be the best idea. Another issue with our approach is that whenever we push and pull, we're dealing with the same linked list linear commit history where everyone adds their commits to the same line of development. This means that your changes are going to affect your collaborators' changes. So the question asked here is, can we isolate changes from each other until they're ready? And the solution is, let's create other lines of development, which are called branches. This means that developers can work independently on in-progress features without interference from other features that other developers are working on. As a hint, this may be useful for the ambition features in Project 3B that Stella was talking about. So now we're going to dive into how branching works and also how we can apply merging to branching. So what branches are they're simply pointers to commits. And generally, they point to the latest commit in a line of development. You can create new branches with git branch name. But all repositories do start off with one branch, normally that's called the main branch. And there's also a special branch called the active branch, which is often denoted as uppercase head. We can set which branch is active with git switch. The active branch is special because when we create a commit, we move only the active branch forward to point to the new commit. And that means that development on the active branch does not affect other branches. And I know there's a bunch of new commands that you're learning today, like git branch and git switch, that you may have not used before. In general, don't worry, we'll go over this soon, but git commands, you don't need to memorize them. You can always search online about them. So an example of what our commit history might look like when we include branching is here. And you can see multiple lines of development. Instead of a linked list, maybe it's starting to look more like a tree. We see that we have a main branch, which is over here, a stars branch down here, and then a cafe branch on top. And we see the head points to the cafe branch. And that means that that cafe branch is the active one. So branching, in summary, allows us to have lines of development that diverge from main. But with diverging, we may need to eventually join these branches back together, and merging helps us with that. So the command that you use here is git merge, and git merge branch name merges the specified branch into the active branch and creates a merge commit, just like with local and remote histories. The merge commit has two parents that are the latest commits in the two branches that were merged. So this is an example of how our commit history might look like when we include merging. We can see that the cafe branch was merged into the main branch. And now we've created this merge commit here with the two parents being that cafe commit and then the initial commit. So now maybe it doesn't look like a tree. Can anyone tell me what data structure this looks like? Graph. And specifically, it's a directed acyclic graph or a DAG. So we've covered what branches are and how merging works with branches, but you don't want to go all crazy with branches. So let's talk about how to structure our use of branches effectively. One way we can do this is the feature branch workflow, which means that all development occurs in branches apart from main, and main is reserved for complete and tested features. Stella will later talk more about why that's important. One convention we can follow is we can name feature branches according to the feature being developed. Again, we be brief but descriptive. And once we finish implementing and testing a feature on its feature branch, we can merge that into the main. So it's very important to test your changes on your feature branch as much as possible. So I have a story to show you just how important testing your feature branch is. During my first internship, I remember on my 4th day, I just got it set up and all, and I got an email that I was assigned a task in Jira. So I was so excited. I opened it up. I was also a little nervous, but I made the changes in the code. It was a couple lines different, and then I merged my changes into main. But the problem was I did not test them up. And my fix ended up introducing another bug into the code. By coincidence, I guess, they were supposed to release an updated version of their product later that night, but they couldn't because I had that bug in the code. So I single-handedly managed to delay that release as a 4-day-old intern. And I just look up like how to revert my changes. And I was like frantically trying to do that. My mentor told me it was like a rite of passage, but I don't want you all to have to do that. So please listen to me when I say test your changes on your feature branch as much as possible.
When you had not written tests or that you weren't running?
No, I didn't write tests, no.
Okay, they just hadn't written at all.
Yeah. Write tests and execute the test and make sure they pass. So now let's see how feature branches can be used to work on code with multiple developers. Let's say that Stella and I are in our second sprint, and we're both initially on the release, the 1.1 commit that you can see here. We're both working on the find friends or on the friends feature, but I'm going to be working on finding friends, and Stella's going to be working on adding friends. I'll create a find friends branch with a commit of the work I've done. You can see that appears up here. And now Stella will create an add friends branch on the bottom with the commits that she's worked on. I'll work some more on find friends. So we see a new commit gets added on top. And now I'm done implementing and testing my find friends feature, so I will merge into main. Git will follow the same steps as before. So step 1, the closest common ancestor is identified as this blue commit on the left here, this release v1.1. And now Git will combine the changes made from that closest common ancestor to the tips of the branches. So one tip is here, and one tip is right here, the ones with the dashed border. The merge is automatic since the changes do not conflict, so Git will then create a merge. Now I'll branch off again, and I can work on another branch with another feature. Now Stella's going to be done testing the add friends feature, so she wants to merge her branch into main. The same steps as before. Git is going to identify the closest common ancestor, which again is going to be this release v1.1 commit right here. And Git will combine the changes made to the tips of the branches, which are in dashed. But we see that on the main branch, in the middle here, friend.java has the find friends method, while on the add friends branch, which is on the bottom, friend.java has the add friend method. And these changes do conflict. So, we're going to have a merge conflict, but you already know how to solve them. So nothing to be scared of if we do encounter these now. So overall, some general advice when working with Git. Be careful with Git commands. It's a good idea to use Git status and Git log periodically to check the status of your commits and your staging area and your commit history. And beware of shortcuts like git add dot or git add star. I know I've used those often, but I try to stray away from those now. Or git push -- force. Google is also your friend. There are a lot of tips online about Git, but don't just blindly copy things from online. Try to understand what they're saying. And again, beware of any shortcuts that people post online. And if Git terminal commands fail, Git will often tell you how to fix them, but don't just blindly follow, understand what they're saying. And again, use Google to help you. And with that, we're going to move on to pull requests, which Stella is going to talk more about.
All right, so Kanav did a great overview of these different branches or using feature branches. And given that we have these feature branches, our main branch is now going to be reserved for deployment. And deployment is the process of making software available to use by users. And actually, CI/CD pipelines use the main branch to test and deploy. So what does this mean? Well, we don't want any development to occur on the main branch. We need safeguards to ensure that we only merge complete, functional, and well-tested changes to main. And this all relates back to the idea of paranoia. And paranoia is the mindset where developers are extremely cautious and thorough in ensuring the quality of their code. And so how do we ensure that we only merge complete, functional, and well-tested changes to main? Well, we do this through something called a pull request, or PR. And that's a way to request that your changes be merged into main. And developers can review your changes, leave feedback, and approve the request. And it's good practice for others to review your code before it's merged. And most major tech companies mandate that at least one other person reviews your code. Most of the time, it's even 2 or 3. And so, fun fact, you could even contribute to open source projects like Firefox by making a pull request. And then a maintainer will review your changes and provide feedback and merge your changes. All right, so let's run through an example of using this pull request process while we work on 621 Belly. So Kanav went ahead and created a sign-up branch to include user sign-up feature and added some cool new buttons. And he commits these changes with a new commit called basic UI. So Kanav now wants to merge these changes with main. But remember, first he needs to create a pull request so that we can ensure main only has the highest quality of code. So once Kanav creates the pull request, it's my turn as a teammate to leave some feedback. And so I left some feedback, so Kanav's going to go take a look at the feedback I've left and push those changes to update his pull request. And lastly, I'm going to take another look at the feedback and the changes he made, and it's all good. So now he can merge to main. So the goal of a PR, as we just saw, is to get feedback on your code. So it's important when you're creating a PR to be explicit about the feedback you want, at people involved, and keep the PR messages descriptive, professional, and informative. And it's very important also to keep the code changes in a PR very small. It's much easier to review a small chunk of code rather than a big one. And so the average PR size, according to GitHub, is just around 50 to 200 lines of code. And just a quick story time, at my internship, the very first one I did, I created a PR, but had no idea what PR even stood for. I didn't know what I was doing, so I ended up filling out a PR without a title, without a description, and I also didn't even test my code. So it ended up taking 5 days to go back and forth with some teammates to better explain what I was trying to do. And so I'm pretty sure I didn't test my code, the style was incorrect, and I ultimately had to create a new PR to get my code changed. And it was only 4 lines of changes. So a key part of the pull request process is that someone leaves feedback on your code, and this is usually called a code review. And so one thing I want to highlight up here is that a code review is kind of like a conversation. So it doesn't just go one way. You can ask a code reviewer to clarify their thoughts. You can ask them for ideas, and it's a really fun collaborative process. And so let's go through an example of creating a PR for 621 Belly on GitHub. So up here, Kanav created a PR for the sign-up page for our 621 Belly app, and he assigned it to me. So you can see the PR has a title, a description, and then a assignee. And so now it's my job to leave some feedback. So I left 2 comments here. One of them is a high-level overview fix, and then another is targeting a specific line of code. And so next, Kanav is going to go fix this feedback I left him. And once he pushes these changes, the PR is auto-updated with them for me to look at. And you can see the new changes are in green and any deleted changes are in red. And so I'll leave my final review, say it's all good to go, and now the PR is ready to merge with main. So you saw it was just one kind of cycle of feedback, but sometimes it can be a back and forth of 10 different conversations. Sometimes it just gets auto-approved because everything looks good. It really depends on what you're working on. And so now let's head into a summary of just everything we've talked about today and why it might matter for you. First, we talked about using Jira for organizing the Agile Scrum development. And this process oftentimes uses a project manager. And we learned how to create the product backlog, sprints, and Jira tickets to manage our project 61 Belly. Second, we talked about Git workflows like feature branches to actually develop these items. We learned about how branching and merging are great tools in Git for us to collaborate with another. And for 61 Belly, we created a variety of feature branches like a login one, photos one, reviews one, and this might be something you want to include in Project 3. Third, we discussed how the PR, pull request, and code review process was key to ensuring good code quality and releasing onto main. And for 61 Belly, when Kanav was trying to add changes to the login page, he first had to create a PR for me to look at those changes, ensure the code was highest quality. So this brings us back to the diagram I showed at the beginning of lecture. That collaboration is at the heart of software engineering. When I talk to students about pursuing a career in software engineering, they often think it's about sitting alone in a coder basement, but I really want to say that's not true at all. It's a very, very highly collaborative role where you're constantly working with teammates, sharing ideas, solving problems together, and all these stakeholders are involved. And so the lesson and takeaway today is that collaboration is key. There's so many opportunities to collaborate with customers, product managers, other engineers, past and future employees, and more. So thank you so much for listening today. We hope we've inspired you to see how collaborative and exciting software engineering is, and good luck on Project 3.
Anyone have any questions?
Not really.
If anyone, if anyone has any questions, we'll be here to answer them. Okay. Skip through that stuff. Jordan's